Right, so I'm going to share my screen so we can go to our notes. All right, and then here we go. So this will be our test 3 study guide. And I'm pretty sure the test always stays in the same order as this we're doing. All right, so first, number one, we want to find the end behavior of the function. So we're going to describe the end behavior of the graph of, so they're giving me p of x equals negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 6. So these were the problems where I had a little chart made up for y'all. On the top of the chart, we had degree, and the degree could be even or odd. And then over here, we had the lead coefficients. And those lead coefficients could be positive or negative. So that it gave me 4 scenarios here. So if it was an even degree and positive, it's going to head uphill on both sides. And if it was negative in the front of an even degree, both sides went downhill. All right, and if you remember, odd with a positive lead coefficient went uphill left to right, and then odd with a negative lead coefficient went downhill left to right. So for the first 2 questions, you need to use that little chart right there. So first, I'm going to look at my degree. My degree is 6, so my degree is even. My lead coefficient is a negative pi, so it is negative. So since this is even and negative, it's going to go downhill on both sides. Okay, so that's all I had to do on that was just look at that end behavior and see what's happening here. So number 2 is the same thing. Choose the correct end behavior for the function. All right, so this one are giving me f of x equals negative 4.8 x to the 4th plus x to the 6th plus 0.8 x to the 7th. So let's see, we're going to find our degree. Now remember, this one's out of order because my highest exponent's at the end. So the 7 is my degree, which is odd. The lead coefficient will be the number in front of that 7, which is the 0.8, and that is a positive 0.8. So since I'm odd and positive, my graph is going to go uphill, left to right. Okay, y'all, so those first 2, that's the main thing. I would just look at your chart there, find your degree, your lead coefficient, and then you're done. All right, for 3, we're going to find the zeros and the multiplicity. So they're giving us f of x equals all right, hang on a second. Let me see what these students are needing. All right, let me answer one real quick about this class. Come on. All right, y'all. All righty, so let me answer this. All right, so we're going to find the zeros and the multiplicity. So they're giving me f of x equals parentheses x squared minus 9 to the second power. So I will say we know, remember, since that 2 is on the outside of my parentheses, that the 2 is going to be my multiplicity. So to find the zeros, I've got to take that x squared minus 9 and actually set it equal to 0. So what I'm going to do on this is use my quad. A will be 1, B will be 0 since there's no x term, and C will be the negative 9. If you punch that on the quad, it'll give you two answers. It'll give you a positive 3 and a negative 3. All right, so let me see. Let me fix something real quick, y'all. I'm going to go back to my main screen. So, are y'all actually hearing me? Anybody?
I can hear you.
Okay.
I hear you.
Okay, because I got one that's saying they can't hear me, so I'm not sure.
I had to dial in.
Okay, they might have to. I'm on my so let me respond here on this text. Alrighty, yeah, so it must be their end on that. So let me go back to my share now. Alrighty, so we've solved it and got our two zeros. So what we would do is come over here. It would ask for my zeros, which are 3 and negative 3. And then each has a multiplicity of 2, because that was that 2 that was sitting on the outside there. So remember that 2 means that this happens twice, and that's how you would get the two different answers for each, okay? Alrighty, so remember, finding zeros is basically setting this equal to 0 and solving them. All right, y'all, number 4, same thing, find the zeros. And multiplicity. This time they're giving us in factored form. I got f of x equals a negative 2 times x minus 2 to the 4th, x plus 5 to the 3rd, and then at the end is a x squared. So the multiplicities will be all these exponents out here, the 4, the 3, and the 2. Those will all be my multiplicities. So what I got to do is take each one of my factors and set them equal to 0. Now, since this negative 2 is sitting here and it does not have a variable with it, we're going to cross it out because there's no way it can be a 0. The 0 has to be these variables. So let's take all the things and set them equal to 0. And then here I'll just set that x equal to 0. So to solve them, I'm going to add 2 to the first one. Subtract 5 from my second one. And then the third one's already solved. So all of these are my zeros. So I would come over here, and my first 0 was 2. And the 0 of 2 had a multiplicity of, the exponent for it was a 4. My next 0 was negative 5. And the 0 of negative 5 came from this factor, so it had a multiplicity of 3. And then my last 0 was 0, and it had a multiplicity of, its exponent was the 2. Okay, so basically just set everything to 0, solve it, and then use them exponents for those multiplicities. Then find, number 5 was find the zeros and multiplicity. So pretty much 3 in a row doing this. The only difference was the type of equations they're giving you. So this one, I got a x to the third minus 2x squared minus a x plus 2. So we've got to solve this one since it's 4 terms. We got to solve it what we call factor by grouping. So you got to group the first 2 terms together and the second 2 terms together. So this is what we call factor by grouping. All right, so you find the GCF from each of these groups. So the GCF of the first 2 terms, the most that they got in common is an x squared each of them. Now the second GCF has the same sign as the third term automatically, so it's going to be a negative. And then x and 2, the only thing we can factor out of those would be a 1. So my GCFs will be the x squared and the negative 1. So you write each GCF in front of those parentheses. Inside the parentheses, I'm going to divide the first 2 terms by their GCF, and then the second 2 terms by their GCF. So x3 divided by x squared will leave you an x minus 2x squared divided by the x squared. Those x squareds will cancel, and just leaves us the 2. On the second one, the negative x divided by negative 1 makes that an x, and then 2 divided by negative 1 makes that a negative 2. So our parentheses matched up, which is what we needed when we do the factor by grouping. So now what you do is you factor out this x minus 2, and you're going to make parentheses for what's left. What's left will be the x squared minus 1. So this is almost like you factoring out a GCF that is parentheses on that one, okay? And remember, at this point, all this, we're going to set it equal to 0. So this factor, I'm going to set x minus 2 equal to 0. And then here, I'll set the x squared minus 1 equal to 0. All right, y'all, so the first one I can solve by adding 2. So I get x is a positive 2. The second one, I'm going to use the quad. A will be 1, B will be 0, and C will be a negative 1. If we punch that on quad, it'll give me 2 answers. It'll give me a positive 1 and a negative 1. So let's see, we've solved everything. So we're going to write our zeros. Now what I'm going to do, since all these have just a multiplicity of 1, because remember, since there's no exponent behind these parentheses, we would treat it like a 1. So my zeros are going to be 2, 1, and negative 1, and all have multiplicity of 1. So that's probably one of the trickier problems to me is number 5 because of that grouping you had to factor, okay? All right, y'all, so next I'm going to hit y'all with some true and false for one of these. So let me turn over. So true or false. If P of x equals x minus 9 squared, x plus 5 to the third, then the graph crosses the x-axis at 9, 0. So this problem, we dealt with the multiplicities, and we said if the multiplicities were even, they were tangent to the x-axis and they didn't pass through it. If the multiplicities were odd, it did pass through the x-axis. So what you got to figure out is to get this 9, 0, it had to come from this factor where the x minus 9 squared is. So that is an even multiplicity. So graph would be tangent. But they said it passes through the x-axis. So since we said it would be tangent, that would definitely be false. All right, and let's see number 7. All right, so this one's not bad. We're going to find the maximum zeros, and those will be real zeros. The maximum x-intercepts, and the maximum number of turns. So they're giving you f of x equals negative 3x minus x to the 4th. So the thing you needed on this problem was what is the degree of this polynomial? And remember, the degree is the highest exponent, which is the 4. So that is a degree 4. So let me write down these 3 things here. I got my max zeros, my max x-intercepts, and then my max turns. Well, the maximum number of zeros equals that degree. So since that's a degree 4, the maximum number of zeros would be 4. Now, since x-intercepts and zeros are the same thing, basically, that means the maximum number of x-intercepts is also equal to the degree, which is 4. So now the only one that's different on this is the maximum turns. The turns is the degree minus 1. So 4 minus 1 would give me 3. And y'all, that was it on that one. So number 8, sketch the graph. All right, so I'm going to show you 2 ways on this one. So h of x equals x and then x minus 2, x plus 2, and then x minus 8. One way you could do this would be by that chart we used earlier with the even degrees and then the lead coefficients. You could get the degree on this one by multiplying all these x's together. So since I got an x times x is x squared, times x is x third, times x would be x to the 4th. So that would be like an x to the 4th. So the degree would be the 4. And then in front of all these x's is a 1. So that'd be like a positive 1x4. So that would be a even degree with a positive lead coefficient. So what I'm going to do is show you how they actually do this on the calculator to get the exact picture they have. So what I'm going to show y'all is how to set a window on that calculator. Because on this one, to match that picture with theirs, notice their x's were the same, but their y values go from negative 100 to a positive 100. So what I wanted to do was show y'all how to set a window on this calculator. So I'm going to go clear that. I'm going to go to y equals and clear that. So first I'm going to put in that equation. So I had an x parentheses x minus 2 parentheses x plus 2 parentheses x minus 8. Now before I graph it, I'm going to hit my window. So I'm going to hit the button that says window. So that's the second one on the top row. Now notice my x's are saying negative 5, so I need them back at negative 10 and positive 10. Then you don't worry about the x scale but then the Y minimum, notice I wanted that to be a negative 100, and I want the Y maximum to be a positive 100. So I've got all them in. So now I can hit graph. And y'all, I'll put the picture here. So if you're looking at that, that's going downhill from the left, but it goes uphill on the right. So the only one that looks like would be, looks like my D here, right? Which I would be happy with, because even degrees with positive lead coefficients, in the long run, we know that both ends go up. Okay, so like I said, there's two ways to do it. You can use your table from earlier, or you can multiply them x's together, get that degree, or graph it, set your windows, and it'll look exactly like their pictures. All right, y'all, number 9 was the same thing pretty much. Except number 9 is it's polynomial form instead of factored form. So I got a 15x to the third minus 12x squared minus 135x plus 108. So if you used your table, that would be an odd degree, positive lead coefficient. So left to right, we're looking for a graph that's going uphill. But I wanted to show you on this one. You got B going left to right uphill, and you got D going left to right uphill. So one way to check is look at this number at the end. That's your y-intercept, 108. Well, this graph is crossing right at the 0. This graph looks like, since that's going to 250, that looks like that's probably crossing at that 108. So I would choose D on that one. But y'all, once again, I'm going to graph it. So I'm going to go y equals and clear this. And I'm going to put in what I got here, 15x to the third minus 12x squared minus 135x plus 108. Now, if you notice, the window on this one is doing the 5s, negative 5, and then my y's are negative 250 to 250. So I'm going to fix that window to a negative 5, positive 5, and then a negative 250 and a positive 250. So by setting the window, I can guarantee that I'm going to get one of those 4 graphs. And if you notice, it definitely looks like number D, because mine was, in fact, crossing over there, okay? Alrighty, so it's not too bad. You got different ways you can sort of check these. All right, number 10, use synthetic division. So now we're getting into the synthetic division to determine if negative 2 and 2 are zeros of h of x equals x to the 4th plus 3x to the 3rd plus 2x squared minus 5x minus 10. So if these numbers are zeros, my remainder will be 0 when I do my synthetic division. So I got to check both of these numbers one at a time. So negative 2, I'm going to check first. I got to write all my coefficients out. So I got a 1, 3, 2, negative 5, and a negative 10. So the only answer I'll get on this is no or yes. Yes if that's a 0, no if it's any other number. All right, so here we go. We bring in that 1 down. 1 times negative 2 is negative 2. 3 plus negative 2 is 1. 1 times negative 2 is negative 2. Then we got 2 and negative 2, give me 0. 0 times negative 2 is 0. Negative 5 plus 0 is negative 5. And then finally, negative 5 times negative 2 is 10. And negative 10 plus 10 give me my 0 remainder. So definitely negative 2 is a 0. So then we would check the 2. And we're going to do the same thing here. So once again, 0 remainder, yes. Anything else, no. So let's see what we do. Bring the 1 down. 1 times 2 is 2. 3 plus 2 is 5. 5 times 2 is 10. All right, let's see. 2 and 10 is 12. 12 times 2 is 24. Let's see. 24 minus that 5 is what? 19. 19 times 2 is 38. And at this point, you wouldn't even have to finish this because you know that's not going to give you a 0. But if you did add it, you got 28, which is not 0. So that one would definitely be a no. Alrighty, y'all. So the next ones are sort of, I'm going to have to turn the page, I think, because number 11 is a little longer. So let me get my next page. So here's the foiling you was waiting on. I'm going to find a polynomial of degree 3. Oh, no, degree 4. So that's a degree 4 with negative 3, a 0, of multiplicity 3, and 0 is a 0 of multiplicity 1. So that's all they're giving me. Now I got to find a polynomial degree 4, which means when I'm done, my highest exponent has to be a 4. So first of all, negative 3 is a 0 3 times. So that means x equals negative 3, x equals negative 3, x equals negative 3. And then 0 is a 0, multiplicity 1. So that would be x equals 0. All right, so remember I had to get zeros on the right side like this one has. So I'm going to add 3 to both sides on all these equations. All right, so now all the equations have a 0 on the right side. So what I'm going to do now is write these and set everything equal to 0. So I'm actually going to put my single x first, and then x plus 3, x plus 3, x plus 3, all equal to my 0. So I'm going to FOIL 2 things at once here. I'm going to do that one, and I'm going to multiply that one at the same time. Now, this one ain't really a FOIL. It's just distributing the x, but here I will FOIL. So I'm going to FOIL there and distribute on this one. So that when I'm done, I'm going to have 2 parentheses still equal to my 0. So y'all, if we distribute this and we get x times x is an x squared plus x times 3 is a 3x. Over here, we're going to FOIL. X times x is x squared. X times 3 is 3x. 3 times x is 3x. And then 3 times 3 is 9. So nothing we can do in this one, so I'm going to bring this one down. But the second one, I'm going to add like terms so that gives me a x squared plus 3 is what? 6x plus my 9 equal to 0. So since we did both of these at the same time, now I just got to multiply one last time, but I do got to FOIL this. So since it's the last things I'm going to multiply, let's see what happens. X squared times x squared is x to the fourth. So there's my degree 4. X squared times 6x is a 6x to the third. X squared times 9 is a 9x squared. Now do these. 3x times x squared is a 3x to the third. 3x times 6x is a 18x squared. And then 3x times 9 is 27x. All right, so it looks like I got like terms, so I'm going to bring down the x to the fourth. The x to the thirds add together, so we got 6 and 3, so that gives me 9x to the thirds. My x squareds will add together, so I got 9 and 18, so what's that, 27x squareds. And at the end is a positive 27x. So all we was looking for is that polynomial. So that's the one we had all the fun foil in it. I just want to let y'all write that for just a second. All right, y'all, number 12 is not as bad. So let's see what they want us to do on 12. So 12 says, suppose a degree 4 polynomial has zeros of, let's see, I got an I and a 4 minus the square root of 5. So degree 4 polynomial has these zeros. Find the other zeros. Well, since this is imaginary, that means they come in conjugate pairs. So if I is a 0, that means negative I has to be a 0. Also, radicals like this come in conjugate pairs. If 4 minus square root of 5 is a 0, then 4 plus square root of 5 is also a 0. So on this one, you don't change the sign of the 4, just the sign that's in front of that radical. You know, that's it on that one. All right, 13 says find a polynomial of lowest degree with zeros of square root of 3 and 3i. Well, one thing we got to realize that if square root of 3 is a 0 and 3i is a 0, then we know negative square root of 3 has to be a 0 and negative 3i must also be zeros. So that my zeros are going to be x equals a square root of 3, x equals a negative square root of 3, x equals a 3i, and x equals a negative 3i. Right, they're trying to see what these are again. Alrighty, so since I got them all set up, I gotta get them on the other side with zeros on that side. So subtract the square root of 3 from the first one. Add the square root of 3 to the second one. Subtract 3i from the third one. And then add 3i to that last one. So if you notice 2 of these, you got no choice but to do a lot of FOILing. So let's set all these into parentheses. All right, so I will definitely multiply these ones 2 things at a time. I'm going to FOIL the first 2. Because since these are conjugate pairs, I'll get rid of the radicals. And then I'm going to FOIL these 2. And since they're conjugate pairs, they're going to get rid of this imaginary stuff. So we know these are going to go into 2 sets of parentheses. So I'm going to start my first one. X times x is x squared. X times square root of 3 is a square root of 3x. Negative square root of 3 times x is a negative square root of 3x. And then negative square root of 3 times a positive square root of 3 is a negative square root of 9. All right, then I'm going to FOIL the second one. X times x is x squared. X times 3i is a 3ix. Negative 3i times x is a negative 3ix. And then negative 3i times positive 3i is a negative 9i squared. So look what we're going to do. We're going to cancel those. We're going to cancel those. And that I squared is going to turn into a negative 1. That's going to multiply by that negative 9 and make that positive. So the first 2, I get an x squared. Those canceled. Square root of 9, I will bring out as a 3. So check that out. Square root of 3 times the square root of 3 is nothing but a 3 in the long run. All right, over here you got the x squared. Those canceled. And that negative 9i squared become a negative 1 times negative 9, which is a positive 9. So check this out. When you multiply conjugates of radicals, they always end up negative. When you multiply conjugates of imaginary numbers, they always end up positive. All right, guess what we're going to do now? Those 2 things will now get FOILed for my final answer. So x squared times x squared is an x4. X squared times 9 is a 9x squared. Negative 3 times x squared is a negative 3x squared. And then negative 3 times 9 is a negative 27. Oh, look here. Those are like terms. So add them together. So that my final answer is the x to the 4th plus 9 minus 3 is 6x squared minus my 27, all equal to 0. All right, so thank God I think that was my last one I had to FOIL. So you had 2 you had to do some heavy FOILing on, 11 and 13, okay? All right, y'all, so looks like we're moving on. $14. They're saying f of x equals x to the 3rd plus 6x squared minus 3x minus 18 has a 0 of negative 6. Find the other zeros. So since that's an x to the 3rd, I'm going to do this one with synthetic division. So they're giving me my first 0 was a negative 6. So since that's an x to the 3rd, I'm going to get 3 zeros. They gave me 1 of them, so 2 are left. Since 2 zeros will be left, I'm going to use the quad to finish this out after I get this negative 6 brought out. So we're going to write our numbers, 1, 6, negative 3, negative 18. Now, since they told me this was a 0, my remainder has to be 0 when I do this, okay? So here we go. We bring the 1 down. 1 times negative 6 is negative 6. Add that together, that gives me 0. 0 times negative 6 is 0. Negative 3 plus 0 is negative 3. Negative 3 times negative 6 is 18, which gives me my 0 remainder. So since I got 3 numbers left, I'm going to use the quad. A is 1, B is 0, C will be -3. All right, so I'm not sure what quad's going to do to that, so let me try that on here. So program, go to quad, enter, and then enter. So A was 1, B was 0, and C was a -3. Now remember, I don't want decimals, so I'm going to hit enter one more time. And that's 0 plus square root of 3, 0 minus square root of 3. So I'm just going to do square root of 3 and negative square root of 3. And then that'd be what they was looking for, was these 2 zeros right here. And then remember, they gave us the -6 would have been the third one. All righty, y'all, moving on. All right, so this one's sort of tricky. We're going to find all possible rational zeros. So they're giving us f of x equals 19 x to the 6th plus 4x to the 3rd minus 6x squared minus 13x plus 2. So this is the one where I found all the combinations of the p over the q, where p is the last number, 2, and q is the first number, 19. So what you had to do was find all the factors of these. All the factors of 2 are 1 and 2. All the factors of 19 are 1 and 19. So we're going to take both of these numbers and divide by both of these numbers. So the first number will be 1 divided by 1, which turns into a 1. So I did 1 divided by 1. Now I'm going to do 1 divided by 19. So that one doesn't reduce, so I'm done with it. Now we take the 2 and divide by the 1. That one will reduce to a plus or minus 2. And then I take the 2, divide by the 19. That one doesn't reduce. So your answer is a plus or minus 1, plus or minus 1 over 19, plus or minus 2, and then a plus or minus 2 over 19. There's no other factors that I can get out of these two numbers, so I'm done. Okay, so that was a trick on that. Just take both the numbers from the last one, divide by both the numbers of the first one. All right, let's see. 16 was find the domain. And it is a f of x equals x to the 3rd minus x squared plus a x plus 2, all divided by x squared plus 11x plus 18. So I'm going to write the domain in both ways because they want you to answer in set builder notation and then in interval notation. So to find the domain, you take that bottom and set it equal to 0. Since that's quadratic, I'm going to use the quad formula. A is 1, B is 11, C is 18. If you use the quad, it'll give you two answers. It'll give you a -9 and a -2. So set builder would be x such that x is a real number and x is not equal to. Now be careful because on this answer, it says it wants it in ascending order. That means from the smallest number to the largest. So between these two numbers, the smallest number is -9, and then -2 would be the larger, and then we're done. So interval notation would be -infinity till I hit -9, union -9 till I hit -2, union -2 till I hit infinity. And I think that's the only reason they wanted you to do the ascending stuff here well, so you would have them in the right order when you put them into your intervals. All right, 17, find the domain. So this one is only going to be put in interval notation. So on top, I got a -2. On bottom, I got an x squared minus 2x minus 35. So just like the problem above, take the bottom, set it equal to 0. I'm going to hit quad on that. A is 1, B is -2, C is -35. If you hit quad, it'll give you two answers. It'll give you a +7 and a -5. So putting that in our intervals, we start at -infinity till we hit that -5. Union that -5 till we hit that 7, and then union from that 7 till we get to +infinity. All right, so 16 and 17 basically to me are the same problems. Don't worry about those tops because I didn't mess with them tops, okay? 18, determine the vertical asymptotes. All right, so they're giving me a g of x is going to equal x to the third over 3x to the third minus an x squared minus 52x. So I'm going to take the bottom, set it equal to 0. So to start this problem, you would factor out an x first. Since every one of these had an x, we're going to factor out the x like a GCF. So that'll leave a 3x squared minus an x minus 52, all equal to 0. So I took one x out of everybody when I brought it out. So now this x is going to equal 0. Here, I'm going to quad a equals 3, b equals -1, c equals -52. All right, so I'm not sure what quad is going to give us on that, so let me hit it again. So quad, I had what, 3, -1, and a -52. So I hit enter. Remember, I don't want decimals, so I'm going to hit enter one more time, and I get 13 over 3 and a -4. Now, these are the possible asymptotes, but remember, since I got a variable on the top, I've got to take the top and actually set it equal to 0 on this one. And x third to the 0, well, the only number I can raise to the third power and equal 0 would be a 0. So notice what happens. 0 is a 0 at the top, 0 is a 0 at the bottom. Those cancel out. And basically, since there's an x in every term, it canceled out of all of them, so that the only answers for these vertical asymptotes would be x equals 13 thirds and x equals a -4. Okay, although you got 3 down here, one of these canceled out with that top because it had the same 0, okay? So to me, 16, 17, and 18 were basically the same because you took the bottoms and set them equal to 0. Only difference was 18, since you had the variable on the top and you're looking for asymptotes, you had to see if anything on top could cancel with the bottom. All right, y'all, so now we're getting down to the determine the horizontal asymptote. All right, so f of x. I actually want to know who came up with that word, asymptote. That's pretty wild. All right, x squared minus 7 over 2x to the 4th plus 3. So to find a horizontal asymptote, I got to look at the degree of the top versus the degree of the bottom. So my degree of the top is going to be the 2. My degree of the bottom is going to be the 4. So the top would be less than the bottom. So anytime the bottom was bigger than the top, or the top is smaller than the bottom, either way you go, y equals 0 is your horizontal asymptote. Had the top been bigger than the bottom, it would have been no horizontal asymptote. Had they been equal, then I would have looked at these numbers in the front for my asymptote. All right, 20 solve. X squared plus 19 is less than 2x. So to solve this, I needed to get everything on one side equal to 0. So x squared minus 2x plus 19 is less than 0. All right, so then I would either factor this or hit it with the quad. Now realize with the quad, if you get radical answers or imaginary answers, then this is a no solution. If you cannot factor it, it's a no solution. So check this out. Are there factors of 19? So 19, the only factors are 1 and 19. Those ain't going to get a 2 by adding, no way in the world, right? So since no factors of 19 will give me a 2, this is a no solution. But also, let's look on the quad. We'll make A1, B negative 2, C 19. So let me go to my quad. 1, negative 2, 19. Notice that gave me imaginary answers with the eyes. So this is a no solution, which means it's the empty set. So a lot of times these tests are really, really similar. A lot of times this is going to give you no solution, but check it anyway, because sometimes they do put a number there that will equal that middle number, and you might get an answer out of it, okay? If you did get those 2 answers, remember, that's where I had to set up the intervals to test them. I did a test interval, and I tested 0 wherever it landed, and then that told me how to shade. But y'all, this one was a no solution, so I didn't have to worry about that, so we're done. So I'm gonna go back to my regular screen. Alrighty, also questions on that. That's the study guide. So if you want to play with that before you actually do the test, the study guide in MathLab will let you work it as many times as you want to, and then you can actually do that test. Okay, so I'm going to start my recording now.